Hi everyone, welcome to your second tutorial in your Introduction to Organic Chemistry unit. This one is on nomenclature, which just means naming things. So if you're doing double lessons, your next one will be on isomerism, which will go in nicely with that, and we'll show you how to name different types of compounds. But this is just a short tutorial going through the IUPAC system for how you would name organic compounds. So we'll go through a couple of examples just to show you how it works. Okay, so the IUPAC system of naming organic compounds consists of a few different parts that you have to figure out and then assemble in the correct order to get the full name of the compound. So these things include a primary functional group, so you need to look at what functional groups are in your compound and find out which one has the highest priority, so that one will be the one that is given the suffix of the name. You have a root name, which comes from the longest carbon chain, so that's down here. We've got a primary carbon chain, that's the biggest number of carbon atoms all joined together. That gives you your root name based on your alkanes. Okay, off this primary carbon chain we may have a number of substituents, and these substituents will be named via prefixes or suffixes. So our primary functional group will be given the suffix, and any substituents that come off it will be given prefixes to just to show that they are there. We also have something called a multiplier. So I'm just going through these words just in case you're unsure, because when I put them in a list of how you would name something step by step, I've used these words just to make it a bit simpler. So a multiplier is if you've got some of the same substituents multiple times, and it's a short part of a name, short prefix that goes before the name of your substituent. So if you've got 2 of the same, you would have di. If you have 3 of the same, tri. 4 of the same, tetra, and so on. So they are your multipliers. And you also have numbers, which are known as locants. They tell you on which carbon atom your substituent is to be found. So once you have figured out all of those different parts of the naming system, then you just need to assemble it in the correct order, and you can name whichever compound you've got in front of you. Okay, so here's our list of things that we need to do, a little checklist. So we've got a compound over here that we're going to name using the system, and down the side we have got a checklist of different things that I'm going to do in this order to help me to name this compound. Okay, so in this first example, first thing we need to find is the principal carbon chain. So that is the longest chain of carbon atoms all joined together. So I can see that there's a long bit here. So if I count here, I've got 1, 2, 3, 4. It would end at 5 if I go that way. 5, 6, or 5, 6. Okay, that doesn't really matter which way I go. So that one is a 6 carbon chain. 1, 2, 3, 4, 5, 6. But I've also got this bit up here, so I need to make sure that I'm not missing that out. So if I include that, 1, 2, 3, 4, 5, 6, 7. So that is actually our longest carbon chain down there. If you were to look at this straight away, a lot of people will have gone for that because it's in the middle and it looks like there are things coming off it. But actually, your longest carbon chain's down there, and this bit is a substituent of your main chain. So I did say in class, using highlighters might be really helpful for this. So I'm going to highlight the longest carbon chain. That's 1, 2, 3, 4, 5, 6, 7 carbon atoms. That is our principal carbon chain. Okay, the next thing to do is to look for our principal functional group. Now, if you look at this compound, there's no real functionality there. It's all carbons, hydrogens, and single bonds, so it's just an alkane. So we don't need to worry about looking for functional groups in there because technically there are none. And the next thing on our list is a root name. So we know it's an alkane. We know because of our principal carbon chain that it has got 7 carbons in it. So remember your system of naming. 7 is heptane. So our root name is based on heptane. Okay, so we've done that bit as well. That's good. So the next thing we need to do is identify any substituents, any parts that are coming off this main chain. So substituents usually like halogen atoms, hydroxy group, something like that, or you can have alkyl chains, so it's a branched hydrocarbon, a branched alkane. So we have got this bit sticking out, this bit sticking out, and this bit sticking out, so essentially like 3 substituents coming off our main heptane chain. So the next thing we need to do is name substituents, so we need to know what you would call those little branch chain parts of the alkane. So these two are the same, and they're based on 1 carbon atom with some hydrogens around the outside. Now if it was an alkane with 1 carbon atom, it would be called methane, but because this is coming off something else, we change the name to methyl. So they are both methyl groups, and this one has 2 carbon atoms in it, which would be ethane if it was an alkane, so because it's coming off something else, we call that ethyl. So we've identified the substituents, and we've also named them. Next thing we need to do is add some multipliers, so if there's any repeated, we need to make sure that we're aware of that. So to add some multipliers, look for the ones that are repeated. In that case, it's the methyl group. We've got 2 methyl groups, so it's actually going to be dimethyl. Di meaning 2. Okay, next step. Number the chain so that substituents are placed on the lowest numbers. So, So number the chain so substituents are placed on the lowest numbers. So you can number this chain from left to right or from right to left. So I'm going to put it both ways. So first of all, going from bottom upwards, we've got carbon number 1, 2, 3, 4, 5, 6, and 7. Now, if you were to name it like that, your substituents would be based on carbon number 2, carbon number 3, and carbon number 4. So your substituent numbers, your locants, will be 2, 3, and 4. Alternatively, you could number it the other way. So we've got carbon 1, 2, 3, 4, 5, 6, and 7. And now you can see that your substituents, if you were to number it this way, would be 1 on carbon 4, 1 on carbon 5, and 1 on carbon 6. So these are our options. You choose the one with the lowest numbers. So we're going to go for the green system of numbering from bottom to top, that way round. Okay, so we're going for the green numbering system. So now you want to add your locants onto your prefixes, which denote your substituents off your main chain. So for your methyl groups, they are located 1 on carbon number 2, 1 on carbon number 3. So you would write that as 2, 3 dimethyl. Okay, so that's your first prefix, 2, 3 dimethyl, that's where they are located. And your ethyl group here comes off carbon number 4, so before the word ethyl, 4 ethyl. So you got 2, 3 dimethyl, 4 ethyl, and that way you have added your locants. Okay, so now you have got all the different parts of the name. You've got a prefix, and you've got a root name, and the suffix in this case is just -ane because you don't have a primary functional group that takes a suffix. And now all you need to do is, as it says here, order the prefixes alphabetically to assemble the name. So when you're ordering alphabetically, you need to make sure that you ignore the multiplier. So this bit, when you do an alphabetical order, doesn't matter. You ignore that. And this substituent you consider to start with M for methyl, and this one starts with E. So obviously E comes first alphabetically, so this is going to be listed first, followed by this, and then the root name. So you end up with the name 4-ethyl 2,3-dimethyl heptane. So it tells you what the root is, it tells you what substituents you've got or what branched parts of the alkane you have got, it tells you where those parts are located, and just to make it systematic and so that everybody's calling everything the same thing, these are listed in alphabetical order. Now if you're quite happy with this and you've made some notes on this, by all means you don't need to keep making notes on all of the different examples. I'm going to go through 2 more examples anyway, and feel free to whiz through. I don't want to waste your time showing you more things, but if you're a little bit unsure or you'd like to see some other examples, then you can carry on watching for the next couple, make whatever notes you'd like. Okay, so here's a second example, and I've used a skeletal formula this time to show you, or mainly skeletal, just to show you how you would name a different type of compound. So again, with this one, the first thing we want to do is identify the principal carbon chain. That's the longest chain of carbons joined together. So if we have a look through here, we've got a very long chain going down the middle, so I'm going to count that one. We've got carbon 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 in a row there. Just have a little look, see if there's no other ways that you could go. So you could start here, but it's going to give you the same, I think. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is your longest carbon chain, and just for simplicity, I'll go right down the middle. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so next we're looking for a principal functional group, seeing what the most important functional group is, and the only functionality we've got is this bromine atom. So halogen atoms are only ever named with a prefix at A level, so we don't need to worry too much about having a suffix on the end. We can class this as an alkane with a halogen prefix on it. If you have a look at your table that I gave you in lesson, it shows all of the different prefixes and suffixes. That'll help as you go through these examples. So moving on to the root name, well, we've got 8 carbon atoms in a row, and we've got all single bonds, so your root name is going to be based on octane, and there's no suffix in this case because there's no functional group that has a suffix. We're just using a halogen atom, which is bromine, and that's going to have a prefix. Okay, so your next thing is to identify substituents, which we've already done. That's the bromine atom, and we need to name them. So in terms of a prefix, bromine is known as bromo. So that's your main substituent. You've also got some branching of your main alkane chain. So you've also got this part, this part sticking out here, this part sticking out there, that one there. It goes all the way that way. Okay, so you've actually got 4 things coming off this main octane chain that's going down the middle. So you need to be able to name each of those. So again, just like in the last one, we've got a CH3 group, which we know is known as a methyl group. We've got the same thing there, methyl group. And this one here has a carbon on the end and another carbon, and then it joins the main chain, so it's 2 carbons in a row with hydrogens around the outside. That one is known as an ethyl group, just like we saw before. Okay, so we've named all your substituents and all your branching of your chains. Your next one is to add your multipliers. So anything that you've got that's more than 1, you need to put a multiplier in. So we actually don't just have methyl, we have dimethyl. That covers those 2, and your ethyl's on its own, so that's fine. And now we are up to numbering the chain so that the substituents are placed on the lowest numbers. So if you have a look at it, you can see that if you were to start numbering from the top, you would end up with your first substituent on carbon 1, 2, 3, 3, 4, 5, 6, 7, 8. Okay, 3, 6, and 8. If you were to number from the other direction, you can see that you'd end up with it on carbon 2, 4 and 4, and 6. So that gives you the lowest number. So we're going to start numbering from down here. Carbon 1, 2, 3, 4, 5, 6, 7, 8 at the top. Okay, and then we need to add some locants, so add some numbers to show where those substituents are. So we're up to this stage here. Okay, so in no particular order, we can see that your ethyl group is on carbon number 6, so that's going to be 6 ethyl, that's 1 prefix. Your dimethyl group, this is an interesting one. Both methyl groups are on carbon number 4 here, one that way and one that way. Now you do actually have to say where both of those methyl groups are, which is a little bit strange. So although both of them are on the same carbon atom, you have to list both of them. So the first one is on carbon 4, the second one is on carbon 4, dimethyl. You have to put the 4 twice. So that's quite important and a little bit strange and seems like a waste of time. And it probably is, but never mind. So 4,4-dimethyl. And your bromine atom is on carbon number 2, so you've got 2 bromo, so there's another prefix, and there's another prefix. Okay, so now we've got the root name, we've got the 3 prefixes, So now you are ordering them alphabetically to assemble the name. So first alphabetically, we've got bromo, beginning with B. So you're going to start with 2, bromo. Next, we've got an ethyl group and a methyl group. So be careful, remember not to include that multiplier on the dimethyl. You just look at the methyl. So ethyl is going to come next. So 2 bromo, 6 ethyl, 4 dimethyl. There's your 3 prefixes. And your root name, octane. Oh, can't spell. Octane. So 2 bromo, 6 ethyl, 4 dimethyl, octane is the name for that compound. And while we've got that name there nice and long, it might just be worth pointing out some of the little conventions in how you write down a name. So I've said this in lessons, but if you've got a number, then a word, you choose a dash in between. If you've got a number and a number, you put a comma in between. And if you've got words and words, you tend to just mush them all together. Okay, so one last example, and this one's another skeletal example. It's a little bit better than the other skeletal one, actually, because it hasn't got carbons and hydrogens on, which was a little bit odd. This one's proper skeletal. So just so that you understand what you're actually looking at, you've got a chlorine here, so there's no carbon, but there's nothing there. So that's a carbon atom. That must be a carbon atom. And up there must be a carbon atom. Coming down here, that's got to be a carbon atom, and that one, there's no carbon there because that goes directly to oxygen. So I'll show you quickly what that looks like in displayed, so that if you want to draw it out, you can do to help you to understand. Okay, so that is what it would look like in displayed formula. If you need that in your book to help you to understand how you name it, that's fine, you can copy that down. Okay, so getting back to naming it. First thing we need to do is find the principal carbon chain. It's the longest carbon chain. Now you can go 1, 2, 3. That's fine. Or you could go 1, 2, 3. Now that second way is going to make more sense because your alcohol group is coming straight off your main chain, and you'll always want your substituents on your main chain because then it's easier to name. Okay. So if you're looking for your principal functional group next, that would be this alcohol group here. So that wants to be part of your principal carbon chain. Okay, so with those two in mind, we can start to come up with a root name. So 3 carbon atoms in a row gives you prop. This time, because of your primary functional group, this bit, you get a suffix. So the suffix for an alcohol, prop and ol. So it's going to be based on propanol. That's your root name. So the root in terms of the number of carbon atoms, and then your suffix on the end as well. Okay, so next you want to identify any substituents off that main carbon chain. So clearly you've got chlorine atom, and up here you've got a methyl group. We know it's a methyl group, it's only showing 1 bond between those carbon atoms, so there's just 1 carbon atom on the end. It must be surrounded by hydrogen. And then we just need to name those substituents. So we've got halogen atom here, chlorine, which when it's a prefix turns into chloro. And this one up here, it's another CH3 group, so as we've seen several times now, that one is a methyl group. Okay, and the only other thing that's quite important in there is your alcohol, but that is already named in your suffix, so that's fine, that's been named. Okay, next we need to add multipliers. So if there's anything that's repeated, any substituents that are there more than once, you need to add di, tri, tetra, or something like that. But as you can see, you've only got 1 methyl group, 1 alcohol group, and 1 chlorine group, so there's no need for multipliers in this example, so you don't need to worry about that. Okay, so next we are numbering the chain so that the substituents are placed on the lowest numbers. Now, with this one, you'll notice that there are substituents, or something, on each of the carbon atoms. So carbon 1, 2, and 3, or 1, 2, and 3. There's something on every one of those. So what you need to do is go back to your principal functional group, which is your alcohol, and make that carbon number 1. So we're going to use that numbering system there, 1, 2, and 3. So now we need to add some locants. We need to say on which carbon atoms these 3 things are placed. So your chlorine atom, based on our numbering system that we've just written in green, is on carbon number 3, so it'll be 3-chloro. Your methyl group is on carbon number 2, so it'll be 2-methyl. And you also need to say that your alcohol is on carbon number 1, because you could maybe have the alcohol here on carbon number 2. It'd be a completely different compound. So you need to make sure that it's clear that that one is on carbon number 1. So the way you do that with an alcohol is you squeeze it in here. So your propanol becomes propan 1-ol. And that tells you where the alcohol group is. And make sure you put it after AN before OL. That's where the number has to go. Okay, so we've got our substituents, we've got our root name, we know where everything is. Now we need to order the prefixes alphabetically to assemble the name. So we've got this one, and we've got this one, and the rest of it is going to be the suffix anyway, so it doesn't matter so much. So looking alphabetically, we've got M for methyl, C for chloro, so your chloro is going to go first. So we're going to have 3-chloro, 2-methyl, propan 1-ol, and that's the name of that compound. I've just rewritten it a little bit in some nicer handwriting. So that's how you would name that one. So hopefully after going through the 3 examples, that should give you a fairly nice idea of how you name things. I think it's a case of drilling and being a little bit repetitive now, and just keep practicing naming these different compounds. So now not only can you switch between using different types of formula, so you can turn a skeletal formula into a displayed formula, displayed into structural, structural into molecular. You can now also interchange between names and formula as well. Okay, one more little thing that I needed to mention is just if you've got cyclic compounds. So we use the prefix cyclo. So for the first one, this has got 5 carbon atoms in a chain. It's all single bonds, the rest are all hydrogens. So it is an alkane, but it's a cyclic alkane. So for this one, you would call it cyclopentane. The next one over, it's just an extra carbon atom, so this one would be cyclohexane. Just means that they're in a ring. And then of course you can have substituents coming off of cyclic alkanes as well. So here you've got bromine atoms. So all you need to do is number so that one of the carbon atoms in the ring has a substituent coming off it, and so that when you do number them, the substituents are based on the lowest number of carbon atoms. So if we call this carbon number 1, if you were to go anti-clockwise, 2, 3, 4, 5, this would be carbon number 6. That'd give you a 1,6, but it's quite clear, you can see if you go the other way, that would actually just be carbon number 2. So this compound here would be 1, 2. It's got 2 bromines, so it's di-bromo. It's cyclic, so cyclohexane, because it's 6 in a row. And that's a skeletal version as well. So I hope that makes sense. If you don't understand the cyclic bit, that's fine. You can just ask me in lessons, but that's just something to be aware of. Okay, and that's all I wanted to cover for IUPAC nomenclature and systematic naming. So hopefully that's helped you. If it hasn't, let me know. If you've got a double lesson and this is the first part, you won't have a post-tutorial quiz yet. You'll have your other tutorial to watch first, and then your post-tutorial quiz after that. Thank you.